Hello. So we're going to look at the section 3.4 quadratic functions applications. So our first one here is a company's weekly revenue in dollars is given by the function below, where x is the number of items produced during a week. R of x equals 2000x minus 2x squared. So our first question is, does R of x open up or down? Well, if we look at our leading coefficient, which is always the coefficient of the greatest degree, so 2 is that here. So our leading coefficient here is -2. And since it is a negative, that means that this opens down. B, would you expect R of x to have a maximum or a minimum revenue? Well, since it opens down, so it looks like this, that means that the revenue has a maximum, because otherwise it goes down on both sides. So next we need to find the number of items that maximizes or minimizes the revenue. And of course it's maximizing. So we are finding, when we're looking for the number of items, and that was our x, we're looking at the x coordinate of the vertex. And our x coordinate of vertex is x equals -b over 2a. So now our a is that leading coefficient, which is the -2, and our b is 2000. So we have -b, which is 2000, divided by 2 times a. A is -2. So the negative signs cancel each other out and become a positive. And then we do 2000 divided by 4, which 20 divided by 4 is 5, and we have 2 zeros left. So that is 500. So 500 is the number of items that maximizes the revenue. Now, next we need to find the maximum revenue, what that is. So what we're going to do is we're going to plug that 500 in where we have the x, and then solve that. So R of 500, that would be 2000 times 500 minus 2 times 500 squared. And this one we're going to take the calculator. 2000 times 500 minus 2 times 500 squared. So how many zeros do we have? 1, 2, 3, 4, 5. So that is 500,000. So that would be the maximum revenue. Next, we need to identify and interpret the x-intercepts. So sketch a rough graph of the function. So x-intercepts are the ones or where the graph intersects the x-axis. So that means that our y equals 0 in those places. So R of x, we're going to set that to equal 0, which means 2000x minus 2x squared. This equals 0. I'm going to take out the greatest common factor, which would be 2x. So I have 1 1000 minus x as the other one, and that is set to equal 0. And I'm going to need more room on this one, so I'm going to continue on the paper. My scratch paper. So 1e. So what did we have? We set the revenue function to equal 0. So we had 2000x minus 2x squared equals 0. And then we took out the greatest common factor. And now we're going to set each of these to be 0. So 2x equals 0. Well, we divide by the 2. So 0 divided by 2 is a 0. And then 1000 minus x equals 0. We subtract by 1000. On both sides, we get... Actually, we should have moved the x, but anyways, we did not. Or I did not. I'm going to divide by -1 to change the signs, and I get x equals 1000. So I have x equals 1000 and x equals 0. So when I do a kind of a sketch of this thing, we have our y-axis here, and then we have our x-axis here. Our 0 is right here. If this here is 1000, then we have that 500 here, which remember was our maximum. Our maximum is the revenue. So we have a 500 and 500,000 is that is our verdicts. So it would be somewhere here, and I'm gonna just put this as the 500,000. So it goes from here all the way up and then comes back down. Oops. And then again crosses the x-axis at 1000. So what does that mean for the revenue? So for the revenue, this here is where the revenue is at its max. So when we go beyond 500, the revenue keeps dropping, and after 1000 it's negative. Here the same thing, from 0 it keeps going up and up. We can't have basically a negative number of well, we could have a negative number of items, but we're basically looking at this. So we start from a 0, and then we keep going up and up until we hit the max on the revenue, and then go down again. Okay, let's look at number 2. So first we need to list everything you know about the graph, then use the quadratic formula to find the equilibrium point algebraically. So what do we know about the graph? We know that the blue line is the supply and the red line is the demand. So when the supply meets the demand, that is the equilibrium point. So our equilibrium point is going to be that supply equals the demand. So if we go to the left of that equilibrium point, that means that we have less supply than demand. And then when we reach that equilibrium point and go to the right, it means that we've got more supply than demand. Okay, so let's find the equilibrium point here. So we're going to move everything to the left, which means that we're adding that 6q squared. So we get 16q squared plus 2q. And then we subtract that 150 from both sides. So we get 16q squared plus 2q minus 150, and that equals 0. Now our quadratic formula. Again, is negative b plus minus b squared minus 4ac divided by 2a. So our a is 16, b is 2, and c is negative 150. Negative 2 plus minus 2 squared minus 4 times 16 times negative 150. And square root of that divided by 2 times 16. So what am I doing? 2 squared minus 4 times 16 times negative 150 and hit the equal. So that is 9,604 divided by 2 times 16 is 32. So let's see, square root of 9604 is 98. So we have negative 2 plus minus 98 divided by 32. So we get negative 2 plus 98 is 96 over 32. So 96 divided by 32 equals 3. The other one is negative 2 minus 98, which is negative 100 over 32. Well, this we don't even have to look at because it is a negative. So we're not going to use that because we can't have a negative value. So the one that we're using is the 3. So now we have to plug this back in over here to our one of these. That's what I was going to say. The supply or the demand. It doesn't matter which one, or actually both of them should give you the same answer. So P of 3, I'm going to plug it in the supply, which is 10 times 3 squared plus 2 times 3. 3 squared is 9 times 10 is 90 plus 2 times 3 is 6. So we get 96. So it's 3 and 96. This is the equilibrium point. And now we can make sure that we did it correctly. 3 is here. Yes, it goes to 3. And if we look at this y-axis here, yes, 96 makes sense. So this is our answer for that. Okay, next one, number 3. So we have a charter flight that charges a fare of $200 per person plus $4 per person for each unsold seat on the plane. If the plane holds 100 passengers and if X represents the number of unsold seats, find the following. An expression for the total revenue received for the flight. Recall that R of X equals price times quantity. So, okay, so the way to set this up is that, remember, X represents the number of unsold seats. So every single unsold seat costs the $4 times the X. So that's all the unsold seats that, or the charge for the unsold seats. Now, the charge for passengers would be our $200 times, if the plane is full, that means that we have 100 passengers, right? But if there's any unsold seats, we have to subtract it from this 100. So we're subtracting that X from here. So 4X plus 200 times 100 minus X. And now we can distribute that and simplify it. So 1, 2, 3, 4 minus 200 X. So 4X minus 200X is negative 196X plus 20,000. So that is your total revenue for this flight. So next we need to graph this revenue expression. So first we kind of have to figure out the y and the x-intercept so that we know where we are. So if we set x to equal 0, we get negative 190 times 0 plus 20,000. Well, this is 0, so it's 20,000. So our y-intercept is 20,000. Okay, I'm sorry about that. My headphones just decided to turn off. Okay, so 20,000 should be somewhere up here. But let's look at the x-intercept. So we're going to set this here, negative 196x plus 20,000 to equal 0. So we move 20,000 to the other side, subtract, and we get negative 196x equals negative 20,000. And then we divide by 100, negative 190x. And we get 20, everything's turned off. 1,000 divided by 196. That is 102. So that is our y-intercept. This one is our x-intercept, right? So, okay. So if we start looking at this, if we go 2,000, 4,000, 6,000, 8,000, 10,000, 12, 14, 16, 18, 20, yeah. So 20,000 is up here. And then we have to go 10, 20, 30, 40, 50, 60, 70, 80, 100. I'm just going to put the 100 here. So it's a straight line. So it goes from here all the way to here. So what is the number of unsold seats that will produce the maximum revenue? Well, that should be a 0, where we get the maximum revenue, which is the $20,000. And so in that case, the maximum revenue, we plug in again the 0 where X is, and we already did that calculation, so we get $20,000. That's it for, oops, I'm sorry, it's not showing the $20,000. Okay, that's it for 3.4. If you have any questions, let me know.